All right, the last thing you need to know this week is how to solve an inequality, which is what we're going to do in this video. So solving an inequality is exactly the same as solving an equation. And they look very similar to the equations we did last week. The only difference is instead of an equal sign, you've got an inequality symbol right here. And these work pretty much the same way as an equation, right? The solution of an inequality makes this statement true. So what I'm trying to figure out is what number can I put in here for v that makes this side of the inequality less than or equal to 9. And there's a lot of numbers I could put in here. I could put 1, I could put 2, I could put 3. There's lots of numbers I could put in here that would make this side of the inequality less than 9, as long as I don't put too big of a number. So how do I sum up what all of those numbers are? I'm going to use inverse operations. I'm going to get v by itself. That's all the same as it was with equations. If I subtract 2 from here and subtract 2 from here, this goes away. Whoop. 2 minus 2 is 0. And I'm left with v is less than or equal to 7. Does that make any sense at all? If you look back at the original inequality, let me just get rid of that. If you look back at the original equality, what this tells me is that as long as v is less than or equal to 7, this will work. Is that true? Well, if I plug in 7, I'll get 9 is less than or equal to 9. That works. If I put in 6, that will also work. If I put in 5 or 4 or 3 or 2, right? When you're solving an inequality, you're using inverse operations to get your variable by itself, and that'll give you that'll tell you what the solutions are here. What numbers can I put in for y to make this side of my inequality bigger than 13, greater than or equal to? So what do I need to do? I have a minus 10 here, so I'm going to do the opposite. I'm going to add 10. I'm going to add 10, I'm going to add 10. Minus 10 and a plus 10 cancel each other out. Those make a 0. And I'm left with y is greater than or equal to 23. And again, does that make sense? Okay. If this tells me that as long as y is bigger than or equal to 23, this inequality will work. And it looks like it does, right? 23 minus 10 is 13. And as long as I just put numbers bigger than 23, it'll also work also. So 24, 25, and so on and so forth. And then again, just a reminder about inverse operations. The way you're solving these is by doing the opposite of whatever is next to your variable. So I've got x divided by 7. I'm going to multiply the whole thing by 7. That's going to undo this divided by 7. And I'm left with x is greater than 14. Here I've got 2 times x is less than 52. I'm going to undo this times 2 by dividing. And again, I think a easy way to show your work for that is to just use a little fraction bar. So 2 over 2, that cancels each other out. And I'm left with x is less than 26, I think. 26. So that's how you solve an inequality. It's very, very similar to solving an equation. The only difference is that instead of x equaling one solution, you've got x being less than or greater than, there's lots of solutions. So go ahead and pause the video and see if you can do the next 2 examples and see if you can do numbers 17, 18, and 19 on page 21. And I'll go through those with you right now when you're ready. So there's actually no instructions here, but what you're supposed to do is you're supposed to just circle the true statements. There's this graph of this inequality. Which of these things are true? Okay, so it says the graph shows the solution of 3x is greater than or equal to 15. Is that true? Well, what is the solution to this? The solution of 3x is greater than or equal to 15 should be x is greater than or equal to 5. And let's see, does this graph match Sorry if you can hear, there's a fly buzzing around in here. So does this graph match this, this solution right here? And I'm thinking it almost does. It's very close, but if it's greater than or equal to, there really should be a closed circle, but it's an open circle. So that does not work. Does the graph show the solution of x is less than, 8 is less than x plus 3? So let's just solve this real quick. I'm going to minus 3, minus 3. This looks to be true, right? X is the, it's opening up to the x. It says 5 is less than x, so x is greater than 5. Yes, that one does work. Does it show the solution of both? Oh my goodness, so, plus 3. I want to add 3 to both sides there, so that matches, and does this match? That also matches. Cool. So A is not true and B and C are true. Which numbers are solutions to this inequality? So really all I have to check for is just plug 4 in for K and make sure that it's less than 21. So 3 times 4 is, yes, that is less than 21. So that works. 3 times 7 is 3 times 7 less than 21. See, this is what's interesting. I get 21. Is 21 less than 21? And that would be a no. 21 is equal to 21. Yeah, this last one's definitely not going to work. I can tell before even doing the math. 36 is definitely not less than 21. That is a false statement. All right, so I'm at the bottom of page 21. Just a couple more examples of solving these inequalities. Again, I've got 3 times x is less than 42. I'm going to use division to get rid of this 3 right here, because 3 divided by 3 is 1. Goes away. And 42 divided by 3. 42 divided by 3. Can't quite do that one in my head. I'm getting 16. And again, how do I know I did this correctly? It's kind of hard to tell with these inequalities. If x is less than 16, that will make this inequality true. Which makes sense to me, because if I go 3 times 16, I get 42. So yeah, as long as x is less than 16, that is going to work. I've got minus 10 right here. I'm going to add 10, I'm going to add 10. I get 25. And over here, this is division. So I'm going to multiply by 2, I'm going to multiply by 2, and I get 16.